Hey there, welcome to this deep dive on Python's data structures. If you're like most of us when we were starting out, you probably had one favorite tool for every single job, the Python list. And hey, it's a great hammer. But what happens when you really need a wrench or maybe a screwdriver? Well, today we're opening up the entire toolbox. Does this sound a little too familiar? You've got a problem to solve and your first instinct is just reach for a list? It's a super common starting point, for sure. But knowing when to use a tuple or a set or a dictionary, that's what really separates a good programmer from a great one. So, come on, let's upgrade your toolkit. So, let's kick things off with a core idea. A great programmer doesn't just know how to write the code, they know why they're choosing a specific tool for a specific job. Each of Python's data structures, you'll see, has its own little superpower, and our goal today is to figure out when to call on each one.
First up, let's talk about our old friend, the list. Honestly, the best way to think about a list is just like a simple everyday shopping list. It is built from the ground up for one thing: flexibility.
Okay, so the crucial things to remember here are its two key properties. First, it's ordered, which means items stay exactly in the position you put them. And second, it's mutable, which is just a fancy way of saying you can change it. You can add milk to the end, cross off eggs, or change bread to sourdough. It's totally dynamic. And all this flexibility comes from a bunch of handy built-in methods. You can tack items onto the end with append or pop them off with pop. You can even insert them anywhere you want. You can sort it, you can reverse it. You basically have total control to modify the list whenever you need to. Now here is a really, really important performance tip. Lists are fantastic when you use them as a stack, like a stack of plates. Adding a plate to the top with append and taking one off the top with pop is super, super fast. But they are terrible when you try to use them as a queue, like a line at a coffee shop. See, adding or removing from the beginning of the list is incredibly slow, because Python literally has to shift every other element down the line. For that specific job, you'd want a specialized tool called collections deck. It's the right tool for that job. So, what if you need data that shouldn't change? Or what if you only care about unique items and you want to get rid of all the duplicates? Well, this is where lists start to fall a little short, and two new tools get to come out and play. First, meet the tuple. At a glance, it looks just like a list, but it's immutable, which means it's unchangeable. Once you create it, it's basically set in stone. This is absolutely perfect for things that should never, ever be accidentally modified, like a specific point on a map defined by latitude and longitude. It's a permanent record. And then we have the set. It follows two very simple rules. One, everything in it is unique. And two, there's no guaranteed order. So if you add Alice to your party guest list 3 times, guess what? She's still only on the list once. Sets are optimized for one thing above all else: checking for membership. Is Bob on the guest list? With a set, that check is incredibly fast. And this is where sets become just awesome. They let you perform all these powerful mathematical operations. With just a simple operator, you can find the difference between two sets. So, who's on list A, but not B? Or the union, that's everyone on both lists combined. Or the intersection, only the people who are on both lists. Trying to do this with lists would be way, way less efficient. All right, next challenge. What if you don't care about the position of an item at all? Instead, you need to look it up instantly using some kind of unique identifier. I mean, think about it. You don't look up a friend's phone number by their position in your contacts, right? No, you look them up by their name. Well, that is the exact job of a dictionary. It doesn't store data as a sequence, it stores it as key-value pairs. And just like a phone book, you use a unique key, like a name, to instantly retrieve its associated value, like a phone number. For lookups, this is unbelievably efficient. And you know what? Working with them is so intuitive. You just provide the key you're interested in to access, change, or even remove its value. And just like with sets, you can do a super fast check to see if a key even exists in your phone book before you try to look it up. It's really slick. So we know our tools. We've got lists, tuples, sets, and dictionaries. Now, let's talk about using them like a professional. Writing clean, efficient, and what we call Pythonic code often really comes down to how you loop over your data. Okay, here's a classic task. Create a list of square numbers. The standard way, right, is to initialize an empty list, loop through your numbers, and then append the result one by one. And look, it works perfectly fine, but it takes up 3 whole lines of code. Now, compare that to the Pythonic way, a list comprehension. It does the exact same thing, but in a single, expressive, and really readable line. You can literally just read it out loud. Squares equals x squared for each x in range 10. Now that is what elegant Python code looks like.
So, what if you need both the item's position and its value while you're looping? A common approach is to just create a manual counter. Again, it works, but it's a little clumsy, right? The Pythonic way is to use the built-in enumerate function. It just neatly gives you both the index and the value together in each step of the loop. It's so much cleaner. And it's a similar story for looping over two lists at the same time. Please don't loop over the index. Instead, use the zip function. It pairs up the elements from your questions and answers lists just like a zipper on a jacket. It's elegant, it's readable, and it's even safer because it automatically stops when the shorter of the two lists runs out of items. Now for a real pro move. What if you want to loop over the unique items in a list, but you want them in sorted order? Well, you can combine our tools. Set of basket first throws out all the duplicates, and then sorted takes those unique items and returns them in a nice, sorted list, ready for your loop. This one line of code is incredibly powerful and super efficient. Okay, let's tackle something a bit more complex. Transposing a matrix. Now that just means we're flipping its rows and columns. So we start with this 3x4 matrix, and our goal is to turn each of those rows into a column. Now, this might look a little intimidating at first, but I promise it's just a nested list comprehension. The outer loop is going through the column numbers, and the inner loop is building a brand new row by picking the element from that column in each of the original rows. It's the same logic we've been learning, just nested. And there's our result, a perfectly transposed 4x3 matrix. Understanding this nested comprehension is really key to mastering how these tools work. And hey, here's a little pro tip. In the real world, you could even do this with the zip function. But knowing the logic behind it is what truly matters. So we've seen all the tools in the box, and we've talked about how to use them like a pro. Let's bring it all together now into a simple guide so you can make the right choice every single time. This slide right here is your ultimate cheat sheet. If you need a general-purpose, flexible, ordered sequence that you can change anytime, use a list. If you're storing a record that should never ever change, use a tuple. For tracking unique items or doing lightning-fast membership tests, a set is absolutely your best friend. And for those instant key-value lookups, nothing on earth beats a dictionary. So the next time you're facing a problem in Python, just pause for a second before you automatically reach for a list. Think about the job you need to do. Do you need order? Do you need to change things? Do you need unique values? Fast lookups? Ask yourself, which tool in my kit is the right one for this job? I promise, choosing correctly will make all the difference.